Okay, so welcome to our last video. So if we look at number 32, we see that we're proving parallel lines, which CP/CTC does not prove parallel lines. However, we can prove the triangles congruent. We can prove parts of the triangles congruent using CP/CTC, and then we can prove parallel lines. Remember, when we're proving parallel lines, we're using the converse theorem, so the converse of the corresponding angles postulate, or the converse of the alternate interior angles theorem, and so forth. So let's get started. We always start with our given, and sorry, these should have little lines above them. P is the midpoint of WY, and P is the midpoint of XZ. That's all we're given. So then from here, we know what midpoint means. Midpoint means it cuts the segments in half. So if I say P is the midpoint of WY, then I can say WP and PY are congruent. And if I know if P is the midpoint of XZ, I can say that ZP and XP are congruent. So that's what I'm going to say in my next step by the definition of a midpoint. So now I have two pairs of corresponding sides congruent. Now I'm going to find something else that I can say congruent about these two triangles, which I can say that angle WPX and angle YPX are congruent by the vertical angles theorem. Or I said it in a little different way. I said ZPY and XPW, same thing. Okay. So now I have three pairs of things congruent on both of these triangles. I can say that these triangles are congruent. If I say triangle ZPY, then I'm going to say triangle XPW, and that's by SAS. Now, in order to prove that lines WX and ZY are parallel, I can use any transversal. I can use either WY or I can use XZ. I'm going to use XZ. And if I want to state that those two lines are parallel, then I would need to say that this angle up here is congruent to this angle down here. And that would be by CP/CTC. Now again, we don't know that these lines are parallel, so I cannot say the alternate interior angles theorem. But what I do know is that these two green angles lie inside of the triangles that we just proved congruent. So I can say by CP/CTC, those two angles are congruent. Now, since those angles are congruent, then I know these lines are parallel. That's by the converse of the alternate interior angles theorem. And that is your proof. All right, if you need to pause the video to write this down, that's okay. But I'm going to move on. So, number 33, we're going to write down our given. I am given that AB and DC are parallel. I'm also given that AB and DC are congruent. Looking at these two triangles, I also, since I have a pair of parallel lines, I can also then use this transversal to say that this angle and this angle are congruent. Those are the only two angles I can say are congruent. So I'm going to say angle DCA is congruent to angle BAC by the alternate interior angles theorem, because I know that these were parallel lines. And then these two triangles share this side in common, so I'm going to say AC is congruent to itself by the reflexive property. So now I have three things congruent in both of these triangles. I can now say that the triangles are congruent by SAS. Make sure your order is good on your vertices. Now I'm trying to prove that AD and CB are parallel. So in order to prove that these two yellow lines are parallel using that pink transversal, I would need to state that this angle here is congruent to this angle here. But the only way I would know that those two angles are congruent is by CP/CTC. I prove that the triangles are congruent, and these angles are within that those triangles, so those angles are congruent by CP/CTC. Now, since I know that those angles are congruent, now I can say that the lines are parallel, because that's the converse of the alternate interior angles theorem. All right, so make sure that you write down everything. If you need to rewind the video to understand the proof, go ahead and do so. But we're going to move on to the next page. We have 2 more proofs left. So we're given the following. So let's mark this. I have angle J and angle M congruent. I have RKL and RLK congruent. And I'm sorry, I just have JK equal to LM. So I apologize. Let me redo that. Okay, so this is what I have. JK is equal to LM. Now, it looks like I'm trying to prove, since AJ is congruent to B, or we're going to try to prove AJ congruent to BM. So it looks like I'm trying to prove this yellow triangle congruent to this red triangle, which on both of those triangles, I have a pair of corresponding angles congruent, and I have another pair of corresponding angles congruent. Now, I only have JK and LM congruent, which if you notice, both of those are not the full yellow or full red sides. So I need to prove that JL and MK are congruent, which would give me the full yellow side for triangle AJL, and it would give me the full red side for triangle BMK. So that's what we're going to do next. Now, if I originally had these congruent, if these were congruent, then we would need to use the definition of congruency to make them equal. However, they weren't, so that was a goof by me. We're going to delete that step because we don't need it. Because I already have that they're equal. So if I have that they're equal, then by the segment addition postulate, I can say that if I take JK plus KL, that will equal all JL. And if I take LM plus KL, that will equal all MK. And that's step number 2. Okay. So then we notice that JK is equal to LM up here. So if I take JK and I substitute it in, LM here, using substitution, I would get JK plus KL is equal to MK. Now you should notice that between these two, JL and MK are both equal to a JK plus KL. So what that means is I can set JL equal to MK. That's either substitution or the transitive property of equality. It's up to you, however you want to look at it. But if I know JL is equal to MK, I do need to state that they're congruent. So that way, I have 3 congruent things on my yellow triangle, and I have 3 congruent things on my red triangle. That's the definition of congruence. So now I prove that JL is congruent to MK. So now I know that these triangles are congruent by ASA. And I did AJL. If I do AJL, my order is BMK. I'm trying to prove that there's a corresponding, these other corresponding sides on these 2 triangles are congruent. So then by CPCTC, I have the sides that I was trying to prove congruent to each other. Make sure to fix all your numbering. They were off. Now this is correct. But I'm going to move on to the next and last proof of this unit. I'm going to have you guys write in angles 5 and 6 here. Also, on your copy, this is fixed, but on my copy, it was not. So I'm going to make sure I write this in my given. FG was perpendicular to FJ. And I have JH as perpendicular to FJ. Okay, so we're going to write our given. which is all of this. So let's mark that on our figure. I have angle 1 and angle 2 congruent. I have angles 3 and 4 congruent. I have FG perpendicular to FJ, so this is a right angle, and JH perpendicular to FJ, so this is a right angle. I'm trying to prove triangle GFJ, so this whole triangle here, congruent to this whole green triangle here that I'm drawing in, which we can automatically see that G is going to be congruent to H. F is the right angle, so that's congruent to J on my green triangle. And J is congruent to F. Okay, let's get started. So for this one here, I can use the reflexive property right away. I can say that FJ is congruent to itself. Okay, so right now in these two triangles, I have a side length congruent. That's all I have right now. I also have these two angles are right angles, which you might be thinking HL. However, in order for HL to happen, we would need to prove these hypotenuses congruent, which is highly unlikely. So I don't think we're going to be using HL. Instead, we're going to be using, we're going to try to prove angle 5 congruent to angle 6 to use ASA on these triangles. So if we're using ASA, then that means we need to state that angles GFJ and angles HJF are right angles by the definition of perpendicular lines. And then we can state that they're congruent to each other by the right angle congruence theorem. Now, using vertical angles theorem, I can say angle 1 and angle 5 are congruent, and I can say angle 2 and angle 6 are congruent. Now, using the transitive property of congruency, I can say, since I know angle 1 is congruent to both 2 and 5, I can say angle 2 and angle 5 are congruent. Now, using the transitive property of congruency again, since I know angle 2 is both congruent to angle 5 and angle 6, I can say angle 5 is congruent to angle 6. So that would give me this. All right, so now I have these triangles congruent because I have on triangle GFJ, I have this angle, I have this side, and I have this small angle here. So that's angle, side, angle. So I can say that the triangles are congruent by ASA. All right, that brings us to the end of our notes. Have a great day.